This is the next section, 8.3. We're going to be focusing in on distributed property. We've already been doing distributed property, but we're going to be specifically multiplying binomials with binomials, binomials with trinomials, and other polynomials with polynomials. So let's begin with this question right here. This is from section 8.2. We already did this. It's distributed property. Go ahead and copy down number 1 and number 2 and do them. So on number 1, I want to explain this nice and slow. Hopefully everybody really understands. If you don't, please let me know. We're going to distribute. See, whenever I have parentheses, yeah, you're supposed to try to do what's on the inside, but you're subtracting and they're not like terms, so you can't do it. So whenever you have parentheses and you can't do anything on the inside, you look at what's on the outside. There's some distributed property here that you need to do. You need to distribute that multiplication of 3x. That's a monomial. Okay, 3x times, you distribute it to the 2x. Now, just this one time, I'm going to explain it very slowly. You multiply the coefficient 3 times the coefficient 2. 3 times 2 is 6. And then you could worry about the x times x. X times x is x squared. Yep, x to the second. And that's where we get the first part of our answer, 6x squared. And then we distribute 3x times negative 5. Well, once again, the coefficient 3 times the number 5, or the negative 5 if you want to call it, that's negative 15. And then the x times, oh, there's no x, you just bring it down. So you put the x right there, and that is your answer, distributing 3x into 2x minus 5. What did we just do here? We distributed a monomial, just to use the vocab that we learned last section, the monomial times a binomial, okay? Everybody understands that, right? Excellent. Now, if we distribute this guy, that's just a constant, negative 7. We're going to distribute that value. Negative 7 times 2x, what is that? Negative 14x. And negative 7 times negative 5, what's that? Positive 35. And done. We got this, right? So if you know how to do these two problems, you technically know how to do this problem right here. Okay. Yeah, copy it down. You see, the difference is up there on the previous two, you were only distributing a monomial or a number, right? And right here, we have parentheses with the binomial, and we have two terms to distribute. So we're going to do one term at a time. So it's kind of like, I'm going to ignore the minus 7. I'm going to start with the 3x, right? And I always draw arrows. I hope you guys do too. It'll help you from making mistakes. The 3x times 2x, we said it was 6x squared. And then distribute the 3x to the other term. 3x to the minus 5, that'll be a minus 15 with an x. And then, we already distributed 3x, so now we need to distribute the minus 7. So let's distribute the minus 7 times 2x, that's a minus 14x, and distribute the minus 7 times minus 5, that's a plus 35. So it's kind of like doing the two problems from above. Once again, just to show you the two problems from above, we distributed 3x, and then we distributed minus 7. That's exactly what we did here. We distributed 3x, and then we distributed minus 7. The only difference is we have one more step. After distributed property, you check and see if there's any combining like terms, which, of course, the two middle terms could be combined. Yeah, that and that. Negative 15 and negative 14 is negative 29, and we're talking about x's. Bring down the 6x squared, bring down the plus 35, and we're done. Yes, multiplying this linear binomial times this linear binomial gave us a quadratic trinomial. Good. Now, we're also going to be multiplying binomials times trinomials and even trinomials times trinomials, and that gets definitely more, not complicated, but it's just more lengthy for sure. We're still going to distribute, we have a binomial here. We're going to distribute one of them at a time. We're going to do the 2x first, and then the minus 1 second. Distributing the 2x, actually let me use a different color here. Distributing the 2x times x squared. Now there's an invisible 1 right in front of it. So do the coefficient 2 times the coefficient 1. What's 2 times 1? 2. And then you could say, okay, how about this x times this x? Well, what's x times x squared? X to the third. So there's your first term right there. And then 2x distributed to the positive 3x. The coefficient 2 times the coefficient 3 gives you coefficient 6. And then the x times x is x to the second. Good job. And 2x times 5, that's going to be a positive 10x. By the way, I know normally when we multiply and we get a positive as an answer, we don't normally put the plus in front of there, but we have to because this is a polynomial, right? You got to separate your terms with those pluses or minuses. Now we've distributed the 2x, let's distribute the minus 1. So I want to distribute this minus 1. Minus 1 times x squared is simply going to be a minus 1x squared, or just minus x squared. Minus 1 times 3x, it just changes the sign, minus 3x. Minus 1 times positive 5 changes the sign to minus 5. Now we have all those terms. What could we combine?
Negative 3x.
Okay. So how about this? When I write my final answer, what should my first term be? Let's start with that. 2x cubed. That's right. 2x cubed. 2x to the third. There are no other x to the thirds to combine it with. That's why we write it down first. Of course, we want it in standard form, highest exponent down to smallest. Let's now move on to combining the x squares with the x squares. And if you'd like, you could circle or box in or underline. I'm going to combine this 6x squared. And when I circle it, notice that I'm including the plus in front of it because that tells me that I have 6, not that I owe 6. And I'm going to combine that with the minus x squared, which is kind of like a minus 1x squared. So I have 6, I owe 1. 6 take away 1 is 5, so that will be a positive 5 of those x squares. Okay. And then we move on to our x's. We have a positive 10x with a minus 3x. That'll be a positive 7x, right? If you have $10 and you owe $3, you're going to have $7 left over. But we're not talking about dollars. We're talking about x's. And what about at the very end? We have a minus 5, the constant. There's no other nice numbers to add it with, so you're just going to bring that down as your constant, minus 5. So right here, multiplying our linear binomial times a quadratic trinomial gave us a cubic polynomial. Any questions? On this worksheet, we're going to practice distributive property, okay? Now I would like to jump to, let's say, 19 or 20 or 17. Why? Because those are trinomials times trinomials, right? And what I'm going to do is I'm going to stack them. All right, what do I mean by that? Well, let me show you. I'm going to first begin by distributing the 2x squared. All right, so 2x squared times 2x squared, that's 4x to the fourth because you add exponents. 2x squared times negative 4x, multiply the coefficient 2 times the coefficient negative 4, and then that'll be a negative 8. And then multiply x squared times x, that's a total of x to the third. Are you with me? Okay. And then 2x squared times 3, we'll just multiply 2 times 3, it's a positive 6, and of course you still have the x squares there. Okay, so I've barely distributed the red circled 2x squared. Now I'm going to distribute the negative 2x, all right? So negative 2x times 2x squared, that's a negative 4x to the third. Now, instead of writing it over here, okay, I'm going to write it over here underneath because I know I'm going to end up combining them anyway, all right? So it's like getting organized. That's what it is. It's like organizing it already. So yeah, negative 2x times negative 2x squared is negative 4x to the third, but I wrote it right underneath the other x to the third. Let me distribute negative 2x times negative 4x. Negative times negative is a positive. 2 times 4 is 8, positive 8, and x times x is x squared, so positive 8x squared. And notice that I wrote it right below the other x squared because I know I have to combine those anyway. And then over here, negative 2x times 3, that's going to be a negative 6x, and there are no other x's, so I just write it right there. And now let's distribute that last term. I'm going to do this one in green. Negative 3 times 2x squared, that's a negative 6x squared. And it's better to organize it by putting it underneath the other x squares. So the answer is negative 6x squared. You put it underneath the other x squares. Negative 3 times negative 4x, that's a positive 12x. And you put that underneath the other x term. And negative 3 times positive 3 is a negative 9. So this is what I call stacking, right? That way it's really easy to yeah, 4x to the fourth plus there's nothing else to combine it with is 4x to the fourth. Now when you combine the negative 8 and the negative 4, you owe 8, you owe 4, you're going to owe 12 of those x to the thirds. And then right here, the positive 6x squared and the negative 6x squared, those guys kind of cancel out and you're left with 8x squared, positive 8x squared that is. And then over here, you owe 6, you have 12, you're going to have 6. 6 of what? 6 of x's. And what about that minus 9? You bring it down. You see, if you wouldn't stack it like this, you would have these 3 red terms, and then you would have these 3 blue terms right here, and then you'd have these 3 green terms way at the end. That'd be, man, that's like 9 different terms that you'd have to combine with circles and underlines. But if you stack them, you already see what you're going to be combining. Combine all these 3, combine these 2. This one comes down, and we end up with a quartic polynomial. Quartic polynomial. Degree 4. Yeah, well, on the test, yeah, we're going to still have the classification. That's why, even though this homework assignment doesn't say to classify, I'm just throwing it out there. Quartic polynomial. Degree is 4. More than 4 or more terms is polynomial. Leading coefficient 4. Constant, negative 9. And that's about it. So this worksheet is pretty straightforward. Let's do number 1. Check it out. And you see, when you distribute, you got to know what you're distributing. What are we distributing here? We're 1q, right? 1q, right? So I could put a 1 if it helps me. If I go 1q times 1q, well, 1 times 1 is 1, and q times q is q squared. Now, we know that you don't really need that 1, so it's just q squared. Okay, q squared. And then q times 5, that's 5q. And then 6 times q, that's 6q. And then 6 times 5, that's 30. And of course, the middle terms, you could combine them. 5q and 6q. 11q. That reminds me of the joke. What's 5q plus 5q?
10q.
You're welcome. Thank you for laughing. Nobody laughed the last class I did that. They just stared at me. It was really weird. Okay. So it's a dad joke. It is. Okay, so q squared minus 11 or plus 11q plus 30. So yeah, keep in mind, distribute quadratic trinomial, that's right. Distribute 1 term at a time and then combine your middle terms if you can. Most of the time you will, but sometimes you won't. You want to try another, or you guys want to get to it on your own?
We can get to it.
Get to it. All right, go for it. Oh, wait. There's one more. The only reason I want to do this one is because there's 2 variables. Right? No, super easy. It's probably even easier. You can't add exponents when you have different. Yeah. So when you go, yeah, it's the only one I think. 3a times 2a, the coefficient 3 times coefficient 2 is 6. And then a times a, that's a to the second, okay. And then 3a times negative b, there's a negative 1 right there. So yeah, you do the coefficient 3 times the coefficient negative 1, that is negative 3. But then you go a times b. What is a times b? It's ab, because ab means a times b, right? So then you distribute negative b times positive 2a. That's negative 1 times 2 is negative 2. And then b times a is ba, but let's put it in alphabetical order, ab. And then b times negative, or negative b times negative b is positive b squared. And could we combine the middle terms?
Yeah, you can.
Heck yeah, what do we get?
Negative 5.
Negative 5 of those ab's. You got the b squared at the end. You have 6a squared at the beginning.
So AB is like its own little thing.
So it doesn't matter like on 10.
So that's a great point that you brought up right here. When I combine this one and this one, when I combine these guys, why isn't the AB squared, since I have AB here and AB there? Right here we're adding and subtracting, right? When you're adding or subtracting, you don't change exponents. When do exponents change? When you're multiplying. And up here on the distributive property part, yeah, for sure, 3a times 2a, you got 6a squared, the exponent changed. But right here where you're adding or subtracting, exponents do not change. Like even down here, or even on the easy one, when I combined 5q plus 6q, it's just 11q. You don't say 11q squared because you're not multiplying. You're just combining, adding or subtracting. Cool? Excellent. All right, guys, so I'm going to end this video here, and I'm going to let you guys work on this, and the solutions are on Google Classroom. All right? Good luck.